This is the solution to the lens equation worksheet, problem number 5. So a 4 centimeter tall object is placed 4 centimeters, which is your distance to the object, 4 centimeters from a diverging lens. Diverging means that it is concave. It's a concave lens with a focal length of 10 centimeters. That means that your image is inside the focal point. So this is 4 centimeters. That means the focus is somewhere out here, because f equals 10 centimeters. Now, because it is a diverging lens, remember, you make your focal point equal to negative 10 because it is diverging. The reason that we do this is because when the light hits a diverging lens, the image ends up going back through here. So before we went to the center of the lens and then went through the focus on the other side, now we go through this focus right here. And now where they crisscross, a little image will be formed. Now, because this is a diverging lens, you already know that it has to be upright and it has to be virtual. Those are two things that it must be just because it is a diverging lens. So now we know that f equals negative 10. We know that it is placed 4 centimeters, so that is your DO is 4 centimeters. So the first thing we are looking for is looking for the location of the image, DI. In order to do that, we must use our lens equation. So remember, 1 over f equals 1 over DO plus 1 over DI. So now we have 1 over negative 10 equals 1 over 4 plus 1 over DI. We're solving for DI, so I'm going to subtract 1/4 from each side. So I have negative 1/10 minus 1/4 equals 1 over DI. Now, a common denominator for this, I'm going to go with 20. Remember, if you can't figure out a common denominator, you can always multiply the numbers together. So I've chosen 20. That means that this is negative 2/20 minus 5 over 20, which is equal to 1 over DI. I do my subtraction. I now have negative 7 over 20 equals 1 over DI. And now to get my DI out of the basement, out of the denominator of my fraction, I can cross multiply or just simply flip over my fractions. And DI will be equal to negative 20 over 7 centimeters, which in a decimal form is negative 2.86 centimeters. Now, if my diagram hadn't told you before, this negative sign with the DI implies that our image will be upright and virtual. So now we know that it is a virtual image, it is upright, and that it is located at negative 2.86 centimeters from that lens. Now, to find the height of the image, we're going to have to use what we know about DI and DO and the original height of the object. The original height of the object, remember, was 4 centimeters. So remember that ratio, HI over HO equals negative DI over DO. So HI is what we want to know. So HI is equal to negative DI DO times HO. So HI is equal to negative 2.86 divided by our original length, which is 4, times the original height of the object, which is also 4. Now, because of the way this worked out, our math is nice. Those 4's will cancel each other out, and it ends up with the height being positive, because these two negative signs will cancel each other out, we'll end up with positive 2.86 centimeters as the new height of the image. Now that image goes along with everything we've said before. It's getting smaller. It was originally 4 centimeters high, but it looks like it's only 2.86. So again, this is another solution for a diverging or concave lens.